So good evening everybody. It's from Jayshree. I am going to take analog and digital converter from the analog and digital ICs under the for the year of second year. From I am from SNS College of Technology. I am going to take this topic analog to digital converter. So what do you mean by analog and digital converter? So, analog to digital converter is a crucial component in electronics, bridging the analog and digital worlds by converting continuous analog signal into discrete digital numbers that can be processed by digital system. Here is an overview of key aspects of ADC. Basic concepts: analog signal. The continuous signal that varies over time, such as temperature or sound or light intensity. Digital signal. A discrete signal with specific values typically represented in binary format for processing by digital systems like microcontrollers and computers. Sampling. The process of measuring the analog signal at the regular intervals. So what do I mean by sampling? Sampling is nothing but if it is an analog signal, if it is analog is a sine wave, we can take the each and every samples from 0 for peak value, and again it is 0 for positive cycle, and for negative cycle again there is a 0 peak value and negative back to 0, right? And analog signal, it's like a watch. In previously we are using the continuous signal watch, right? But nowadays they are using the digital signal watches. Okay. Quantization. Assigning a digital value is each sampled point. That is what quantization. Okay, this is what R2 or ladder type. So here it is convert analog signal into digital signal. Here the input we are giving as the voltage and output we are taken as the each and every samples. R2 or ladder. R2 or it's like the circuit is connected like a ladder. R2 or which three circuits are seriously connected and which is given as the input to inverting terminal of the amplifier. And non-inverting amplifier which is indicated by plus symbol, which is connected to ground. Okay, and feedback resistance RF is connected between output to the inverting terminal input. Okay, what is my A to D converter? The types of ADCs. There are three types of ADCs. Number one, successive approximation ADCs, flash ADC, and dual slope ADC. Okay. So what do you mean by successive approximation ADC? Uses a binary search algorithm to convert the analog signal into a digital value. This is what the prawns: high accuracy, moderate speed, and widely used. Most complex circuitry. Okay. Next one, flash type ADC. Uses a bank of compactors to convert the input to a digital output in a single step. Flash type ADC. Flash nothing but we can pass the light. Okay, and this uses the bank of compactors to convert the input signal to the digital output in a single step. Prawns very fast. Cons: high power consumption, large size, and expensive. Okay, sigma delta ADC uses oversampling and noise shaping to achieve high resolution. Prawns: high resolution accuracy and good for low frequency signals. Slower conversions rate. Okay. Next one is what? Dual type ADC. Integrates the input signal over the period and then measures the time it takes to return to zero. High accuracy, noise resistance, slow conversion time. Okay. These are the applications of analog to digital converter. We have seen so many applications, but the particular specific applications are audio and video equipment, medical devices, industrial control, communication system. Converting sound and video signals to digital form for processing and storage. Next one, medical devices, measuring biological signals like ECG or EEG. Next, industrial control, monitoring sensors and control systems. We have to monitor each industry values, right? This is what this circuit represents. And converting signals for digital transmission and processing. These are the applications of analog to digital converter. Audio and video equipment, medical devices, industry control, industrial control, and lost communication systems. So the three types of unlock to converter: successive, flash, and dual through. So thank you all. Have a nice day.